Hello again, kids. So, in this video, we're going to talk about the classification of quadrilaterals. We have studied very thoroughly triangles. We haven't finished studying triangles, but before we go deeper into triangles, we're going to now visit quadrilaterals. A quadrilateral has four sides and four vertices. Four sides and four vertices. So here we have a family of quadrilaterals. We're going to write down in a very precise way what is the definition of each of the following six quadrilaterals. And you need to know this by memory. Like, you will never hesitate again. What is a square? What is a rectangle, a rhombus, a parallelogram? And maybe you have defined this in lower school, but now we're going to define it in a high school, very deep way. So, rectangle. A rectangle, the word rectangle, rectangle, it has four right angles. That is the definition that we're going to be using for rectangle. A square. So, a square, it has four right angles. And also, the four sides are congruent. All the sides are congruent. Now, the rhombus that, all the sides are congruent. Now, in a rhombus, all four sides are congruent. In a rhombus, I don't have to be a square, no? Like, it is like a flattened square. A parallelogram, I have two sets of parallel sides. So this side is parallel to this side, and these two sides are parallel. In a trapezoid for Americans and a trapezium for Brits, these two sides are parallel and the other two are non-parallel. So in a trapezoid, I have only one set of parallel sides. And a kite, as we call them in Mexico, a papalote, I have two sets of adjacent congruent sides. Like, this is the same as this, and this is the same as this. Beautiful. So those are the definition, the more general definitions of this quadrilateral. Now, we need to ask ourselves the following questions. So, for example, we're going to write down for each of the quadrilaterals which properties do they satisfy. So, two sets of parallel sides. Yes, that is a parallelogram. I have two sets of parallel sides. This is parallel to this, and this is parallel to this. Do I have four congruent sides? No. Do I have one set of parallel sides? No, I don't have exactly one. I have two. I have one set of congruent sides. Like this, if you just look at it, we will prove it, but this measures the same as this, and this measures the same as this. It's like a flattened rectangle, no? So, do I have four right angles? No. Do I have four sides? Yes. A trapezoid, I don't have two sets of parallel sides. I don't have four congruent sides. I have exactly one pair of parallel sides, and I have four sides. An isosceles trapezoid. So a trapezoid, it's like a normal thing like this. An isosceles trapezoid, apart from having a pair of parallel sides, the non-parallel sides are congruent. So here I do have one set of congruent sides. I have one set of parallel sides of C then D, and I have four sides. A rectangle. A rectangle has four right angles, yes, but it also has two sets of parallel sides. It has four right angles, and it has four sides. Then I have the rhombus. A rhombus has exactly all the sides are congruent. If you look at a rhombus, so I have two sets of parallel. If you look at a rhombus like a diamond in the sky, I do have two sets of parallel sides. I don't have four congruent. I do have four congruent sides. Mr. Cachoa, I have four sides. And in a square, I have the exact same as a rhombus, plus that I have four congruent sides. Four right angles. Excellent. And a quadrilateral only has F. Now, which description was used the most? Very clearly, it was F, because all of the quadrilaterals have have four sides. Why some shapes have more descriptions than others? Because some are particular cases of others. For example, if you look at a square is a rectangle, but a rectangle that has four congruent sides. A rhombus is a parallelogram, but a parallelogram that has four congruent sides. And a square is also a parallelogram that has four congruent sides and four right angles. Which one was the one with the greatest number of description? It was very clearly the square, because a square is at the same time a rectangle. Sorry, my arrow should be like, the square is a rectangle, the square is also a rhombus, the square is also a parallelogram. Excellent. So this is a question that I'm going to ask once. One of these shapes is convex and the other one is concave. If all my angles are smaller than 180, then my shape is convex. All are smaller than 180. Remember that 180 is this, no? It's like a flat line. So for example, here I have an angle greater than 180. No, it's greater than the flat line. So this one is called concave. Two words that you need to know. Beautiful. Now let us complete this Venn diagram. So a Venn diagram is used in set theory to describe like the universe of quadrilaterals. So my universe is the universe of quadrilaterals. So notice that on one side I have my parallelograms, and on the other side I have my trapezoids. So here, this distinction is because in one I have two sets of parallel sides, and in the other I have exactly one set of parallel sides. Outside that it's not a parallelogram nor a trapezoid, I have the kites, no flying around because they are kites. Kites don't have any parallel sides at all. But they are not classified into more categories. So in parallelograms, I can have the parallelograms that have four right angles. The parallelograms, you know, like that, they are parallelograms because they have four right angles. Not every parallelogram is a rectangle, because I could have like parallelograms that are like this. And I also have the parallelograms that have all sides the same, or the plural of rhombus is rhombi. So here all the sides are the same. And in between, the parallelogram that is at the same time a rectangle and a rhombus is a square. So a square has 4 right angles and 4 congruent sides. That is why it is at the same time a rectangle and a rhombus. On the other hand, trapezoids can be very interesting by themselves. So we have the isosceles trapezoid. You know, like I have one set of parallel sides and one set of congruent sides. This is my isosceles trapezoid. Isosceles like in a triangle, right? So I also have another type of trapezoids that are very similar to triangles in the way that we classify them. They are called the right trapezoids. The right trapezoids are the ones that are always right, low. No, the right trapezoids are the ones that have right angles, no? That the non-parallel sides create, one of the non-parallel sides, it makes a 90-degree angle with the parallel sides, no? So this is an isosceles because I have 2 congruent sides, and this is a right because I have a 90-degree angle. Excellent. So to finish the classification, to almost finish the classification with the quadrilaterals, we need to answer the always, sometimes, never questions. So a square, well, if I look at the diagram, squares, all the squares are inside of the bag of rectangles. So always a rectangle. A parallelogram is, now I have a big bag of parallelograms and inside I have the rhombuses. But some of my parallelograms have not to be a rhombi, so it's sometimes a trapezoid, and a rectangle. Like, I don't have anyone shared in between trapezoids and rectangles, so here my answer is never. A rhombus is a square. I have some rhombuses that are not squares. Like squares live inside rhombi, but not always, so only sometimes. And a rhombus, well, the little bag of rhombi live inside of the universe of quadrilaterals. So a rhombus is always a quadrilateral. So to finish with this, I have here 2 congruent sides. These 2 angles are congruent, and here I have a right angle. What is the most specific name that you can give to this? So it is very clear then, because these 2 sides are congruent, then these 2 sides have to be congruent. So if I have 2 adjacent congruent sides, what I have is a kite. So this is a kite. Beautiful. So having said that, that is the video about classifying quadrilaterals. Among the universe of quadrilaterals, we have a particularly interesting quadrilateral that it's called a parallelogram that we will study in our next video that is a part of this same class.